A six-legged machine walks through a Finnish forest like an ant the size of a bus. In Austria, a harvester works a slope so steep it has to be held there by a steel rope. In California, a logging machine sets wood on fire on purpose and locks the carbon away for thousands of years. Every one of these breaks a rule. Engineers spent a century writing, no CGI. Every one is real. 10 machines, 10 rules, snapped clean in half. Number 10. The Bell Tri-Wheeler Lugger. Start with the most basic assumption in vehicle design. 4 wheels. A rectangle of contact with the ground. It's why cars have 4 wheels, why tractors have 4 wheels, why almost every skidder ever built has 4 wheels. Take one away and you get a tripod, and a tripod on a slope is a machine looking for a place to fall over. In 1964, a South African engineer named Irvine Bell looked at that rule and decided it was wrong. Bell invented the tri-wheeled loader, originally built for sugarcane, then adapted for forestry. And it did something a 4-wheeled machine physically cannot do. With 3 wheels and an articulated frame, it pivots in almost its own length. It turns inside a plantation row. It gets into a compartment, grabs a bunch of pulpwood, spins and drops it without ever needing the swept turning circle that a conventional skidder demands. And here's what makes it an engineering story, rather than a novelty. The stability that a 4th wheel was supposed to provide. Bell got somewhere else, from geometry, low center of gravity, weight biased over the drive wheels, a boom that works with the machine's balance instead of fighting it. The load itself becomes part of the stability equation. The design was so effective that Bell has kept building versions of it for 60 years. The company's own history notes that many manufacturers tried to copy the tri-wheeler concept, and none of them made it stick. Bell eventually built a hybrid of it too, called the Skogger, essentially a cross between the 3-wheeled logger and a conventional skidder. 4-wheel drive, designed to gather and extract timber in field, with a target price around half that of a full-size skidder. That's the trade the whole machine represents. Give up 1 wheel, gain a machine that costs less, weighs less, fits between the trees, and gets more wood out per rand than the corrected design ever could. Rule broken. Stability is not a function of wheel count. It's a function of where you put the mass. Number 9. The leveling feller buncher. Every excavator ever built shares one design assumption. The house sits on the undercarriage, and whatever angle the undercarriage is at, the operator is at too. Tilt the tracks 20 degrees, the operator tilts 20 degrees. That's just how a machine is built. That assumption is fine on a construction site. In steep timber, it's a productivity ceiling and a safety problem. An operator sitting at an angle all day is fighting gravity with his spine. Worse, a boom swinging out over the downhill side of a tilted machine is a rollover waiting to happen. The tracked feller buncher itself is a fairly recent invention. The commonly cited origin is 1968, when logging equipment developer Irv Drott mounted a shear-type felling head on a knuckle boom on an excavator base, the ancestor of every tracked buncher working today. But the machine that broke the rule properly was the Timco. Wisconsin-built Timco pioneered the leveling tracked feller buncher, a machine where the entire upper structure, cab, engine, boom, everything sits on a hydraulically actuated leveling frame that keeps the operator flat while the undercarriage does whatever the mountain demands. The lineage runs straight into today's machines. Take the Timber Pro TL745D. Its upper structure levels 4 ways, up to 24 degrees forward, 7 degrees rearward, and 24 degrees to either side. There's an automatic leveling function on a button. The machine reads the slope and corrects itself. Underneath it, a Cummins L9 putting out 350 horsepower, long heavy-duty track frames, and a wide stance for stability. Think about what those numbers mean in practice. A conventional machine starts feeling seriously unsafe somewhere around 20 degrees. The leveling machine simply resets its own horizon and keeps cutting. But the deeper win isn't safety statistics. It's that the boom now swings in a predictable plane. The operator's sense of where the head is doesn't get scrambled by slope. He can put a 30-inch stem exactly where he wants it, on a mountainside all day. The operator does not have to share the ground's opinion about which way is up. Number 8. The 20-ton forwarder. Here's a physics problem. You want to carry 19 tons of cut logs across a peat bog. The bog will not support 19 tons. Discussion over. That's what the textbook says. Build a road or don't harvest the site. The forwarder answered this by attacking the wrong half of the equation. Everyone assumes the problem is weight. The problem is actually pressure. Weight divided by contact area. And contact area is something an engineer can buy. Take the John Deere 1910G. For years, the largest forwarder in Deere's line. It carries a rated load of 19,000 kilograms, nearly 42,000 pounds. It's driven by a 200 kilowatt, 268 horsepower engine with roughly 230 kilonewtons of tractive force and a crane reaching 8.5 meters. Now look at how it stays on top of the ground. Bogie axles, pairs of wheels on a walking beam, so the machine climbs over obstacles instead of stopping dead against them. Over the bogies go steel tracks, which turn two wheels into a single long contact patch. And the geometry is deliberately obsessively tuned toward flotation. Here's the number that makes the point from Ponce's own engineering data on its harvesters. A six-wheeled ergo exerts about 850 grams per square centimeter of surface pressure. The eight-wheeled version of the same machine, about 280 grams per square centimeter. A 20-ton machine on the right running gear presses down on the forest floor with roughly the same intensity as a person standing on it. The engineering doesn't stop at the ground. The 1910G can be specified with a rotating and leveling cab that turns through 290 degrees. The operator physically swivels to face the load he's building instead of craning his neck backwards for 10 hours. And Deere's intelligent boom control lets the operator command the grapple's position, while the software works out the lift, slew, and extension needed to get it there. And the class keeps growing. Deere's newer H-Series introduced 20-ton and 25-ton forwarders, the 2010H and 2510H. Rule broken, weight was never the constraint. Ground pressure was, and ground pressure is negotiable. Number 7. The TigerCat Carbonizer. Every machine in this video so far exists to cut wood, move wood, or process wood. This one exists to burn it, but not the way you think. After a harvest, you're left with slash, limbs, tops, stumps, rotten wood, brush. It has almost no value. Chipping it and trucking it away often costs more than the material is worth. Pile burning it puts the carbon straight back into the sky, and leaving it in place in fire country is how you build a fuel bed for a catastrophe. TigerCat's answer came out of a company called Ragnar Original Innovations, which TigerCat acquired in 2019. The prototype became the 6050 Carbonator. After a ground-up redesign, it's now sold as the 6040 Carbonizer. Here's what it actually does. You feed woody debris, logs, limbs, brush, stumps, pallets, clean lumber into an open chamber with no pre-processing. Under air and over air fans control the oxygen precisely, so the material doesn't simply combust to ash. It carbonizes. Replaceable thermal ceramic panels line the chamber. On the 6050, those panels were rated to 1,650 degrees Celsius, 3,000 Fahrenheit. What drops through the grates isn't ash, it's organic carbon. Biochar. An auger trough at the base quenches it in a water bath, and a conveyor carries it out. The numbers TigerCat publishes for the 6040, in-feed volume reduced by roughly 90%. Around 25 to 30% of the total available carbon in that wood is captured and sequestered, locked into a stable form. Average throughput, 15 to 20 tons per hour. It needs 450 to 680 liters of water an hour to quench the output, and the whole thing runs on remote control, including driving the machine. The biochar isn't waste. It goes back into the soil, where it behaves like a sponge, holding water and nutrients and releasing them slowly. A California ranching and forestry operation profiled by TigerCat has been disking it into rangeland, mixing it with compost and manure first, applying roughly 10 tons of the mixture per acre. Rule broken. The residue was never the problem. The assumption that it had to be moved was number 6. The Mountie Tower Yarder. Every machine we've covered has to get there. Drive to the tree, cut the tree. That's the definition of ground-based harvesting, and it is the reason huge areas of mountain forest were, for most of history, effectively unharvestable, too steep, too broken, too dangerous. Cable yarding throws the whole premise out. Don't bring the machine to the wood. Bring the wood to the machine through the air. The Austrian firm Conrad Forsttechnik, founded in 1990 by Josef Conrad, who started with 4 employees, builds the Mountie. Picture a heavy truck chassis with a steel tower folded on its back. It parks on a forest road. The tower goes vertical. A skyline cable is rigged from the tower out across the valley or up the mountain, anchored to a stump or an anchor tree hundreds of meters away. The specifications on the Mountie 4000, tower height around 13 meters, operating length of 600 to 800 meters, winch pulling force of 40 kilonewtons, with cable speed up to 5, optionally 8 meters per second. It's built on a Mayen truck chassis in the 400 to 440 horsepower range. Then a carriage runs out along that skyline. Conrad's woodliner is self-propelled with its own integrated winch. The lift liner is drawn. Either way, it travels out, drops a line, picks up a turn of logs, lifts them clear of the ground, and hauls them back. And this is the part that genuinely rewrites the rule book. On the Mountie, the crane and the operator's cabin rotate fully around the base of the tower. So one operator, sitting in one seat, controls the carriage as it runs out and back, releases the automatic chokers, then swings the crane around and processes the logs on the spot with a woody harvesting head, delimbing, measuring, cutting to length, and stacks the finished product for the timber truck. Conrad's woody heads come in sizes handling stems up to about 75 centimeters in diameter. Joseph Conrad had a blunt reason for building it. Logging is among the deadliest occupations on Earth. Conrad has cited European figures in the range of 24 to 30 fatalities per 100,000 workers. Every meter of steep ground a man doesn't have to stand on is a meter he can't fall down. Rule broken. The machine doesn't have to reach the tree. It only has to reach the rope. Number 5. The EcoForce T-winch. Here's the thing. Every off-road engineer accepts as gospel. Grip comes from friction between the tire and the dirt. Steeper slope, less usable friction. Past a certain angle, your wheels spin, your machine slides, and no amount of horsepower saves you. Untethered machines start becoming genuinely unstable somewhere around 20 degrees. 2 brothers in Austria, Markus and Johann Krenn from Tragus, spent years logging steep ground with cable cranes and decided the whole premise was negotiable. Their idea: what if the machine's traction didn't come from the ground at all? What if it came from a rope? The T-winch is a compact, tracked, remote-controlled winch. It parks on solid ground, usually a forest road, and anchors itself. A steel rope runs from the winch down to the harvester or forwarder, working the slope below. The winch maintains constant, actively managed tension on that rope as the machine drives. The forestry machine is now, in effect, hanging, not dangling, but continuously supported. Its wheels no longer have to generate all the force needed to hold it against gravity. They only have to steer and roll. The consequences are dramatic. EcoForce reports wheel slip values under 20%, meaning the machine's tracks and tires stop tearing and shearing the soil, which is what causes rutting and erosion in the first place. Fuel consumption falls because the machine isn't burning diesel spinning its wheels. And crucially, tethered systems let ground machines work slopes approaching 45 degrees, terrain that previously demanded a full cable yarding operation. The engineering pedigree is worth knowing. EcoForce was founded formally in September 2014 and delivered its first production machine to Switzerland in February 2015, 12 units in the first year. The current lineup runs from compact units up to the 40.344 tons, a 324 kilowatt 441 horsepower FPT engine, and a maximum pulling force of 250 kilonewtons. The T-winch 30.2 also runs 441 horsepower on 1-inch rope with a nominal constant pulling force of roughly 40,000 pounds force and is rated for machines from 10 to 80 tons. And there's a beautiful detail. The T-winch is fully remote controlled, and if the operating position on the mountain can't be reached by any normal means, the winch pulls itself up the slope. EcoForce calls it extreme mode, Rule broken. The ground was never the only place to get grip. Number 4. The Ponzi Scorpion King. Look at any excavator, any crane, any harvester built in the last 100 years. The boom is mounted in front of the operator. Of course it is. That's where you can see it. The problem, that boom is also a large steel object permanently parked in your field of view. And a harvester operator's whole job is judgment. Which stem to take, which way to fell it, where the pile goes. Every second he spends leaning around a boom is a second he isn't cutting. Ponzi started rethinking the operator's world in 2007. They had a prototype by 2008, and the company's founder, Einari Vidgren, looked at it and wasn't satisfied. They tore it up and started again from zero. The Scorpion launched in 2013. The higher-powered Scorpion King followed. The solution they landed on sounds insane until you see it work. Mount the crane on a base behind and to both sides of the cab and route it up and over the operator's head. The C50 crane is a hydraulic parallel crane with a 2-armed lifting boom reaching 10 or 11 meters with a 280-degree turning angle and a gross lifting moment around 252 kilonewton meters. It uses a multi-chambered extension cylinder to synchronize the booms rather than heavy steel beams, lighter and needing far less maintenance. But the crane is only half the story. The chassis broke a second rule. Instead of one frame or two, the Scorpion has 3, connected by rotating joints. The front frame carries the front wheels, the rear frame carries the engine, the hydraulics and the rear wheels, and the middle frame carrying the cab and the crane is kept hydraulically level, up to 15 degrees fore and aft and 12 degrees side to side, while the front and rear frames just tilt with the terrain. Because the pivot point for lateral leveling sits very low, the operator doesn't get swung around. The center of mass stays on the machine's center line. Then there's the stabilization system, which is patented and genuinely clever. Sensors track the crane's slew direction. Pressure sensors read the lift cylinder. From that, the control system works out exactly how hard to press the rear frame in the direction the crane is working, actively counterweighting the load. And it does this while the machine is driving. If there isn't enough stabilizing force available to keep the machine safe, the system stops the machine. 8 wheels spread the mass. The whole thing typically weighs about 22,500 kilograms on a Mercedes-Benz engine making around 286 horsepower. One more detail that says everything about the design philosophy. Ponzi built the Scorpion out of high-strength steels. Strength 700 MC plus in the crane arms, strength 700 in the chassis, Hardox 450 in the head, cutting weight so the boom could move faster and the machine could float better. It won the International Swedish Steel Prize in 2015 for it. Rule broken. The crane doesn't have to be in front of you. It can be above you. Number 3. The Conrad Highlander. Conrad again. And this time they went after the most fundamental division in all of off-road engineering. There are 2 families of ground machine. Wheeled machines, fast, gentle on the ground, useless when it gets truly steep or broken. Tracked machines, superb climbers, but slow, heavy, and they chew the forest floor. Every machine you have ever seen picks a side. A Highlander refuses to pick. It's a wheeled harvester. 4 wheels on the HL10, 6 on the HL20, with all-wheel drive, a switchable hydraulic differential lock, and big drive wheels. On a forest road, it can run it up to 30 km. 2-wheel, 4-wheel, and crab steering with a short wheelbase make it absurdly maneuverable in a normal stand. And then the terrain gets vertical, and the Highlander does something no wheeled machine is supposed to do. It extends telescopic feet. It uses a portal tandem axle, and it moves through a synchronized step-and-drive motion, pushing itself forward with its legs while its wheels drive, adapting its stance continuously to whatever it's standing on. Automatic level compensation keeps the machine stable and keeps the crane's swinging power constant. Conrad's own description is blunt. The Highlander was developed for steep terrain, and it works efficiently in places where the alternative isn't another harvester, it's a cable crane. The rest of the machine is built around the same refusal to compromise. The crane is mounted behind the cabin for a completely unobstructed view, with continuous rotation giving a full 360-degree working envelope, And the crane, cabin, and harvester head can all rotate endlessly in either direction because Conrad builds its own rotator with the hoses routed internally. Hydraulic hoses run inside the boom, out of harm's way. And when even that isn't enough, there's an integrated, synchronized traction winch. The HL20 can be optioned with up to 90 kilonewtons of adjustable pulling force on a 14mm, 300-meter cable, usable as a rigging winch. So, a machine that drives like a wheeled harvester, climbs like a tracked one, walks when it has to, levels itself constantly, and can tie itself to the mountain when the mountain wins. Rule broken. The wheeled versus tracked trade-off is not a law of nature. It's a design choice, and Conrad refused to make it. Number 2. The Menzie Muck Walking Excavator. Every excavator on Earth solves the slope problem the same way. It doesn't. It flattens the slope. You cut a bench, you build a pad, you make the ground fit the machine. In 1966, in Switzerland, 2 men decided to make the machine fit the ground. Edwin Ernst Menzie and Josef Kaiser built a prototype excavator designed to work on mountainsides. The partnership famously fell apart. The two ended up as rivals, but both Menzie Muck and Kaiser AG have been building these things for nearly 60 years since. Here's the design. Delete the fixed undercarriage entirely. Replace it with 4 independently articulating limbs, each one able to extend, retract, and pivot on its own, each ending in a powered wheel or a hydraulically extending claw. The cab and boom sit on a rotating house on top, like a normal excavator. Now the machine can do something no conventional excavator can. It doesn't level the ground. It reconfigures itself until it is level on whatever the ground happens to be doing. The capability numbers are hard to believe. Spider excavators regularly work slopes exceeding 100%. That's a 45-degree grade. On steep ground, the rear legs extend stabilizing claws that anchor the machine and build it a safe level platform out of nothing. Add a winch and it goes steeper still. It can wade into water around 2 meters deep depending on the machine. And because the mass is distributed across 4 widely spaced points, ground pressure is far lower than a conventional excavator of the same weight. Take the current flagship, the M545X, introduced at Bauma in 2019. It weighs about 13,500 kilograms, travel speed 15 km/h, maximum lifting capacity around 9,800 kilograms. Thanks to a boom cylinder mounted horizontally through the center of the machine. It has 4-wheel, crab, and front or rear axle steering. Its wheels can be spread to a track width of over 6 meters for stability, and it has up to 2.2 meters of ground clearance. In forestry, it takes a mulcher, a winch, a felling head, a processor. It can plant a foot, brace, and use that foot to push, pull, and lift itself through terrain where nothing else can stand up. There's a reason these aren't everywhere. They're expensive. The electro-hydraulic control systems are complex, and most excavation in the world happens on flat urban sites. But when the job is on a mountain, in a riverbed, or in a slip, nothing else is even in the conversation. Rule broken. The machine does not need a level base. It can build one out of its own body, anywhere. Number 1. The Timberjack Walking Machine. In the mid-1990s, Plustech built a harvester that walks on 6 articulated legs, like an insect. This wasn't a stunt. It was an engineering answer to a real, expensive physical problem. Wheels and tracks damage forest soil. They compact it, they shear it, they cut ruts, and those ruts aren't just ugly, they become channels. Rainwater runs down them, and you get erosion, root damage, and long-term site degradation. The industry has spent decades and enormous sums fighting this with bogies, tracks, brash mats, and flotation tires, all of them mitigating a problem that is inherent to rolling contact. A leg doesn't roll, a leg places. Each foot comes down, takes its share of the load, and lifts again. The machine's weight is spread across 6 independently controlled contact points, and it never drags. It steps. The gait was modeled on how an ant moves. An onboard computer controls the walking. The operator sets the parameters, and the machine works out where to put its feet, only handing back manual control when an obstacle is genuinely impassable. A separate control and measurement system handles the crane and the cutting head. What it could do sounds like science fiction. It walked forward, backward, sideways, and diagonally. It turned on the spot. It stepped over obstacles rather than climbing them. It had adjustable ground clearance, and it leveled itself automatically, the body staying horizontal regardless of the angle of the forest floor beneath it. If you want more machines like this, subscribe and tell me in the comments which one you'd actually want to run for a day. I'd take the Spider.